All right, guys, this is Miss Murphy, um, and I'm going to be talking about lesson 9.4, which is all about range, mean, median, quartiles, mode, and interquartile range, which in other words is called measures of central tendency. Now, all of these different measures of central tendency can look at different things. So the measures of the center, so any measurement that can talk about the center of our data, are going to be mean, median, and mode. All right, and we'll talk about what those mean in a second. Whereas measures of the spread or the distribution can come from our range, our quartiles, and our interquartile range. So when we're talking about spread, that's kind of when we're looking at a histogram and saying, okay, why does this graph look the way it is? Why is there more on this side than this side? Or is it kind of centered? Or is it skewed? And that is what we're going to look at. So for right now, we're going to talk about how to find these different things. And then later, when we talk about outliers and measures of variability and all of that, we're going to actually dive deeper into how they affect each other. But for right now, we're actually going to be discussing how to find these different things, which most of them you should already know how to do. I think the only thing that's new to you is the IQR interquartile range. All right. So let's just hop right into it. So we're going to start with probably the most common one that you will hear, which is mean. All right. So when it comes to mean, that is the sum of data divided by the number of pieces in the data. And more often than not, you will hear this as the average of a set of data. So again, you basically add up all the data and divide it by the number of pieces. So in other words, how many data points do we have? So for example, if I'm looking up here, all right, this is my data set. All right. So we would we would add up all these data sets, which they do here, and we divide it by how many numbers that we have, which in this case, if we count 1, 2, 3, 4, 5, we have 5 numbers. So we're going to divide it by 5 here. So first things first, we're going to add these numbers up, which you can do fairly easily in your calculator. So I have 10 plus 12 plus 18 plus 19 plus 32. I'm going to hit enter. That's 91. So I'm going to put 91 right here. And then I'm left with 91 divided by 5, or what we're more used to, 91 over 5. Now, that one you may have to put straight into your calculator because, of course, 91 is not, or 5 does not go into 91. 91 is not divisible by 5. It does not come out into a nice number. So we are most likely going to get a decimal. So I'm going to just hit divide by 5 so that I'm automatically dividing 91 by 5. That's why it says answer here. And I get 18.2. And that's exactly what I'm going to state my range. My mean is 18.2. So if I want to put these numbers in a context, let's say I was talking about the number of minutes someone spends getting ready in the morning. And we took a data set, and this was the number of minutes that we came up with if we talked to 5 different people, which, by the way, is not a very big sample size. But let's say that someone said 10 minutes, someone said 12, 18, 19, and 32. If we want to know the average time that people took to get ready in the morning based off of these data points, we would say about 18.2 minutes is the average time someone spends getting ready in the morning. So that's kind of putting what we just found into a real world content. So when we're talking mean, we typically are going to see mean in terms of histograms. You see it sometimes with dot plots. And occasionally we can see it with frequency tables. Well, frequency tables kind of tie into histograms, but those are typically the ones that mean really matters in terms of its center, specifically histograms. And we'll dive more into this in our next lesson when I get back. All right, now we're looking at median, which you guys should know means the middle. So it's data that occurs in the middle. So keyword, middle. Now, when we are finding this data, you always have to list your values in order from least to greatest, especially if you're doing it by hand. Now, I told you guys how you can find it in your calculator, but you still need to know how to do it by hand, regardless of whether you do it in your calculator or not. Because remember, EOC, you do have a calculator inactive and active section, and it's also something that you've been doing a while, so it should be fairly familiar to you. So when we're finding the middle term, so this will be the first example right here. So let's say this is example 1. What I like to do is I just cross out one from each side until I get to my middle. And remember, you should have the same number of tick marks on either side. So if I cross them out one at a time, and I like to do the tick marks backwards, my median would be 18. That's my middle. Now, our second example, let's do the same process. So I'm just going to cross one from each side. Now, I have 2 tick marks, but only 2 numbers left. So remember, if you're left with 2 numbers in the middle, you have to take the average of those 2 numbers to get to your median. So in other words, you would add the 2 together and then divide it by 2, which is the number of terms you have. So 13 plus 15 is 28 divided by 2. That means our median for this one is 14. Now, if it was the same number of the 2, you would just have to just use that number. But if your middle is between 2 numbers, even if you can kind of already tell what halfway is, still add them together and divide by 2 to make sure that you got it for sure. Now, with median, what you will see this the most with is box plots. You can also see it with dot plots as well. So dot plots is kind of like a general that you see a lot with either mean or median. Kind of the kings of centers in terms of statistics is either mean or median, and it really depends on what you're looking at. Now, when we talk about outliers and spread and how our data is skewed, there is a relationship between the mean and the median of a set of data and how our data is distributed. But we will get more into that when I come back. But again, the biggest graphical representation you will see median with is box plots as its center. The next we have is mode. So with mode, it's data that occurs most often. So this does not mean it's the highest point in the data. It means that it occurred this many times more than the others. So more often than not, your mode is 2 or more times. and you look for the number or numbers that have appeared more than once, and whichever one appears the most times, that's your mode. Now, if none of your numbers repeat, there's just no mode. So, for example, with this set of data, if I'm looking at all of my numbers individually, the only number that repeats is 18. It repeats twice. So because of that, my mode is 18. Now, it is possible to have, so you can make a note of this, it is possible to have more than one mode or no mode. So maybe two different numbers were repeated the same number of times. That could be the mode. Or if you just don't have any numbers that repeat, that's no mode. So mode is not really seen as often with center. Where mode comes into play is mode deals a lot with frequency. If it's the mode, that means it occurred the most, that particular statistic occurred the most frequently in our subset. So that could also go along with, all right, was that around where our average was? Was that around where our middle was? What did we see the most often and why did we see that? So mode really gives us another point that we can analyze in our data sets, especially when we graph them. But in terms of graphs that have mode in them, all the graphs that we have seen have mode. It's just a matter of how we use it to describe certain scenarios. So we kind of need it more in a context. All right. Now we're looking at when we're talking about spread. So this is measure of spread. So not really so much in the center, but in its spread. So the first one we're going to talk about is range. So the easiest way to remember this one is a range of numbers. So the range is just a difference between the greatest number and the least number. So remember, difference means you're subtracting. And so basically, when we're talking about the range, we're basically saying, okay, how many intervals or numbers are between my least and my greatest number? So for example, with the example over here, our minimum is 10 and our maximum is 32. So we would just do 32 minus 10, and our range would be 22. That means that between 10 and 32, there are 22 different numbers or outcomes that could occur if that's what we're looking at. So, like if we were specifically looking at whole numbers, or we were looking at the number of baskets that someone makes in a season of a basketball game. And the minimum was 10, the highest was 32. That means between all the different players, there could be any number of those 22 different outcomes. That's typically what range means. There's this many outcomes that we can see between these two numbers. So that really does describe our spread because it does tell us where we're going from. So we're going from this number to this number. It kind of gives us a more discrete outlook of where our outcomes or our data is. Now, we then have our quartiles. So we talked about this yesterday when we were doing box plots. So quartiles are simply values that divide data into four parts, into four quartile parts. Or not quartile, my bad. For equal parts. So in other words, given our set of data, we should be able to find the first and third quartile. Now, like I said yesterday, first quartile, third quartile, you may be wondering, well, where's the second quartile? That second quartile is the median. So that is technically our second quartile. Now, in terms of spread, they may not be evenly distributed. Our median may be closer to our third tile than our first quartile, or our quartiles may be closer to our minimum than our maximum. We will talk about later what that means in terms of our data. However, when we're looking at data that we are given, that is where we can figure out where our quartiles are. So they gave us this handy dandy little box plot that we've already discussed about, and it's just a remarking of what the different parts of the box plot means. But if I want to find my quartiles, all I got to do, like for example, I'm just going to rewrite the one of the examples that we did for median. So I got 10, 12, 13, 15, 16, and 17. So we already said our median was here and that it was 14.5. Now, we then got to find the first quartile, which is the median of the left side or the lower side, and then the third quartile, which is the median or center of the right side. So on the right side, the median. So I'm going to cross out on the left. So 12 is my first quartile. I'm going to cross out on the right. 16 is my second quartile, or third quartile, my bad. And of course, 14.5 is my median. So that's how you would find those quartiles. Again, you can also do them in your calculator, but it's also very important that you know what those means. Those quartiles mean that we separated our data into even parts. Now you're wondering, like, I count 3 parts, where's the fourth? The fourth comes in the form of your minimum and your maximum. So your box plot looks at your first quartile, your median quartile, and your third quartile. The box itself does. The fourth quartile comes from your least and greatest value. You're actually separating them. You're actually separating the fourth quartile into 2 parts, which comes in the form of your whiskers. And again, we're going to talk more in depth about what that means later on, specifically when it comes to outliers and how that can affect the way your graph is distributed. But for right now, as long as you can find those quartiles, that's the most important part. And remember, all 5 of these different aspects of your box plot, those are all part of your 5-number summary. So if I ever say you need to find your 5-number summary, I mean you need to find your minimum, your maximum, your first quartile, median, and your third quartile, whether you're making it into a box plot or not. So just know that that's what I mean by a 5-number summary. Now, lastly, we have our IQR, which stands for interquartile range. Now, all an interquartile range is that it is the difference between the upper and lower quartile. So in other words, we would do Q3 minus Q1, and that would give us our IQR. So essentially, all the interquartile range is that if we took a range of the box here, so of our actual box, we want to know what numbers span or are contained within that box. What data sets could we possibly get within that box? So again, you would do Q3 minus Q1. So of course, when you're trying to find the interquartile range, you always got to find the median first, because if you don't know where the median is, you can't get your other 2 quartiles. You then find the median of the first part. So in other words, that'll give you Q1. And the median of the second part, that'll give you Q3. And then you find the difference of the two. So in other words, you would do Q3 minus Q1, and that will give you the interquartile range. So if I break this apart for this example, I will first find the median. So I'm just crossing my numbers out as I go. And I'm left with 18 as my median. That's my middle. Now from there, I'm going to find the Q1. So I'm going to look to the left of that 18, and I'm just going to do more crossouts. And then 16 would be my Q1. My Q3, I'm going to look at the right side of the 18 and do my crossouts. I'm left with 28 as my Q3. So I'm hoping to do Q3 minus Q1. So that means I'm doing 28 minus 16. And that would give me 12 as my IQR, or interquartile range. Now, in a later lesson, we will discuss how to use your interquartile range to find things like outliers or parts of our data set that may not fit in the spread that we're looking for. And we'll talk about that in our next lesson when we do outliers. But for right now, with all of these measures of central tendency, I just want you to be able to find them. So all of this should have been reviewed except for possibly your interquartile range, which that is totally fine. So if you have any questions on this, please feel free to email me, but you should have everything you need to go ahead and start working on your Delta Math. The packet work is pages 10 through 11. If you finish your Delta Math and if you finish everything, I do have another assignment for you guys, so see the sub for that. All right, I will see you guys on Monday, and thank you so much for watching.